This is question number 10 from the AP Review. It asks us to find the sum of this series. The only infinite sums that we've learned how to take the sum of, and the only ones we will, are telescoping and geometric series. The way it's set up here, it certainly doesn't look like it's telescoping. We also can't do partial fractions because this isn't factorable down here. So it's most likely, especially because it's raised to an exponent here, it's most likely going to be a geometric sequence or geometric series. We want to try to rewrite it so that it looks more like what we're used to for a geometric series. So I've got -2 to the n, and then I've got e to the n plus 1. I can write e to the n plus 1 as e to the n times e to the first. When you multiply, you add up the exponents, so I can split up this n plus 1. So both of these are to the n, so now I can write it as -2 over e all to the n. And then I've also got this e on the bottom. So I have something times something to the n. This is a geometric series. The sum of a geometric series is the first term divided by 1 minus r. So our r value is -2 over e. Our first term, if I plug in 1, I would get -2 over e times 1 over e. So my first term is -2 over e squared. And then we want to try to match it up with one of these. Notice also that the option of the series diverging is in there. This formula only works if the series is converging. So we do need to double check to make sure -2 over e is about 2.7. So this is a value less than 1. So it does converge. To find what it converges to, I'd clear out the fractions. I'm going to multiply the top by e squared to cancel this guy here out. I can do that as long as I also multiply the bottom by e squared. So I get -2 over e squared plus 2e, which is choice B.